So today here we've got the 200 inch-pound steering torque with precision, angle, as well as angular rate channels coming out. Here you'll see we have the actual steering sensor that is powered by a 9-volt battery, which has a on-off power switch here. Also has a shunt calibration button over to the side. We have the infrared receiver with the tooth gear here that accepts the plastic chain that runs from the steering sensor drive gear over. This will be suction cup mounted to the windshield. And then we've got a signal conditioning box here that provide power and ground to through a cigarette lighter adapter or an AC adapter. And the encoder, which is this guy over here, will plug in. And then coming out, we have a torque signal out, and then there's a low and high resolution steering angle out, as well as an angular rate out as well. And we'll take a look at what this setup looks like. So as we're going to install this in the vehicle, you'll notice that there are these little brackets with a hoop on them there. And this, combined with some heavy-duty tie straps, will allow us to quickly and securely to the steering wheel. You'll notice that the center is open, which will allow for airbag-friendly testing. We will not have to remove the airbag in order to install this wheel. So see, I've got the zip ties on there now. We'll go ahead and trim those off. You want to do your best to center the wheel. You want to get as little up and down movement out of the steering wheel in order to help the gear drivetrain and everything go through. So we've got our encoder and our wheel mounted. So I've trimmed off the zip ties there. I've got my drive gear routed, playing with the gear here, and you'll notice that as I turn the steering wheel, you'll see some up and down movement on the encoder there. That's to account for the steering wheel not being perfectly centered. Once we've done this, we can go ahead and make some electrical connections. To wire our signal conditioner, I've got a cigarette lighter adapter plug here. We'll see we've got power now. And we go ahead and install the encoder output cable. Those two are wired. Now I'm going to install the torque output cable here. This will go to a single LEMO connector that I have, and that's going to go to our data acquisition. And then the other cable here, it contains the high resolution angle out, low resolution angle out, as well as the angular rate, and that's on 3 separate LEMO connectors here that will interface with our data acquisition. You'll notice that we've got a display on the screen there, as well as a green indication when we have good data being received from the infrared transmitter. And I will go ahead and turn on the steering wheel. And we'll notice now that I'm getting a green light, and we'll actually see some things change here as I apply some slight torque to the steering wheel. So we'll go ahead and get this interface with the data acquisition, and we'll get this set up. 200 inch-pound steering torque sensor is installed in the vehicle now, and I have installed the connections at analog channels 3, 4, 5, and 6. So you'll notice that I've got channel 3 is my steering torque signal, and then I've got the 2 different angular position channels. One is a high resolution, one is a low resolution with a larger full scale, and then there's also a steering rate as well. So for the calibration of these, I am using essentially 10 volts at 200 inch-pounds, and then I'm taking that to a maximum level of 200 inch-pounds. And then for the angular sensors, and this is supplied in the documentation, but we have 10 volts is
plus or minus 409.6 degrees on the high resolution channel. And then on the low resolution channel, this vehicle steering wheel won't go that far, but we can actually take advantage of several additional turns of the wheel before we hit full scale there. And this channel set up at 10 volts at 1638.4 degrees, and I'm only taking that to a maximum level of 500 degrees plus or minus. That is as far as my steering wheel will travel. And then I've got a steering rate here that you can see is set up as 1,000 degrees per second at 10 volts with a maximum level here of 1,000 degrees per second. And you'll notice if I steer my wheel back and forth very quickly, you can see all of these channels work. So as I very slowly turn, I've got somewhere in the 24, 25 inch-pound steering torque. And this is actually sitting in grass, stationary with the vehicle running. And then you'll notice some of my angles and my angular rates and things there change as well.
So I've got a live channel screen set up here with a few of the channels from our steering wheel. As you'll notice, we've got steering torque, angular position, angular rate, then I've got vehicle speed, lateral acceleration, and steering angle coming from the CAN bus of the vehicle as well. So if we'd like to go for a little drive here, you can see some of these things live update on the screen. The steering wheel is convenient to steer from. It sticks out a couple of inches past the standard size steering wheel, but it's still natural to use. Can still reach my turn signal and all those good things. So you'll notice as I apply a little bit of torque back and forth that we'll actually see that bar change a little bit, as well as the steering angle.